Welcome back to Miss Max Academy. In this screencast, we're going to learn how to find an arc measure. The measure of a minor arc is equal to the measure of its corresponding central angle. Just to review, a central angle has a vertex at the center of a circle, and its sides are radii of the circle. So in this diagram, our central angle would be angle RST. So central angle RST would be equal in measure to arc RT. So if central angle RST is 50 degrees, the measure of arc RT would also be 50 degrees. The measure of a minor arc is equal to the measure of its corresponding central angle. Once again, the measure of arc RT would be equal to the measure of its corresponding central angle, RST, which would be 50 degrees. The measure of a major arc is the measure of the related minor arc subtracted from 360. So what would be the measure of major arc TQR? TQR. Well, 360 take away 50 degrees is 310. So the measure of major arc TQR we expect to be 310 degrees. Once again, the measure of a major arc is the measure of its related minor arc subtracted from 360. Finally, we all know the measure of a semicircle is 180 degrees. One more thing I'd like to talk about before we move on and do some example problems is the word or the vocab term adjacent arcs. Adjacent arcs are arcs of the same circle that have exactly one point in common. You can add the measure of adjacent arcs just like you can add the measures of adjacent angles. Earlier in the year, we used to say the whole equals the sum of its parts. So that means the measure of arc ABC should be equivalent to the measure of arc AB plus the measure of arc BC. The whole equals the sum of its parts. Let's try some example problems. What is the measure of each arc in circle O? Well, before I move on and do this problem, I'd like to mark up my diagram. If central angle BOC is 32 degrees, I know arc BC is also 32 degrees. I can clearly see that CA is the diameter of the circle and would cut the circle exactly in half. So 180 minus 58 should be 122 degrees. That would be the measure of minor arc DA. Did you check my math? In fact, I was correct. I could be abysmal with my addition and subtraction sometimes. You know what they say, you don't use it, you lose it. So that means central angle DOA is also 122. Well, what would be the measure of angle, let's see, or arc BA? Again, arc BA would have the same measure as central angle BOA. And you can clearly see here that these two angles form a linear pair. They're two angles that form a line and add up to 180 degrees. So to calculate angle BOA, I would do 180 minus 32. That should be 148 degrees. And if central angle BOA is 148 degrees, then minor arc BA is also 148 degrees. Okay, so let's make sure before we move on that all of our math is correct. We know all the central angles of a circle should add up to 360. So let's just double check. 32 plus 58 plus 122 plus 148. In fact, is 360. And likewise, all the arc measures on a circle should add up to 360. Now I can come on over and answer these questions. Well, what's the measure of minor arc BC? And clearly we can see minor arc BC would be 32 degrees. It's equal to central angle BOC. What's the measure of minor arc BD? There's a couple different ways we could do that. The easiest way is we could add minor arc BC plus minor arc CD. So 32 plus 58 should be 90 degrees. So in fact, we have a right angle right here. Let's see. Let's change this. Angle BOD, in fact, is a right angle. What is the measure of major arc ABC? ABC, actually ABC is in fact a semicircle, so it's just 180 degrees. It's pretty simple. And finally, what's the measure of arc AB? And the measure of arc AB is 148 degrees. We have that clearly written here. Let's add another question. Let's call it E. What is the measure of major arc DBA? So from D, past B, all the way to A. From D, past B, all the way to A. There's a couple different ways we could do it. Maybe the simplest way to do it in this case is we know the whole circle is 360. And major arc DBA is everything but 122 degrees. So the easiest way to find the measure of arc DBA would be 360. Sorry, my pen is being a little funky. Subtract 122 degrees. Which would be 238 degrees. Let's do an example that allows us to use our Algebra 1 skills to find the measure of an arc. In this problem, we're going to find the measure of arc IJ. Arc IJ is given by the algebraic expression 15x plus 10. We've been given a central angle here of 147 degrees. We know that this central angle is equal in measure to its intercepted minor arc, HJ. So minor arc HJ has a measure of 147 degrees. And finally here, we have minor arc HI, which has been given to us using the expression 6x plus 14. We know all three of these arcs form the circle. Therefore, the sum of these three arcs must be 360 degrees. The whole equals the sum of its parts. So let's start with our algebraic equation. The sum of these three arcs must be 360 degrees. So 6x plus 14 plus 15x plus 10 plus 147 must be 360. Our next step would be to simplify the left-hand side of our equation. We do that by combining like terms. 6x plus 15x would be 21x. 14 plus 10 plus 147, that's 157 plus 14, is that 171? Just double check my math. So now, this equation is now simplified to 21x plus 171 equals 360. We want to solve for x, so we're going to subtract 171 on both sides. When I subtract 171 on the left-hand side, 171 subtract 171, they cancel each other out, opposites add to 0. When I subtract 171 on the right-hand side, I am now left with the equation 21x equals 189. Our last step in order to solve for x would be to divide both sides by 21. If I divide the left-hand side by 21, 21x divided by 21 is 1x. If I divide the right-hand side by 21, 189 divided by 21 is 9. So now x equals 9. I still need to find the measure of minor arc IJ. So what do? I plug it in. Minor arc IJ was given to us by the expression 15x plus 10. Wherever I see an x, I'm now going to plug in its value or substitute its value, x equal to 9. So the measure of minor arc IJ would be 15 times 9 plus 10, which is 145 degrees.